So today, inshallah, we're going to continue discussing the single-phase power transformer. Last class, we derived the equivalent circuit of transformer. This is in this shape called a exact equivalent circuit. طبعا this is exact equivalent circuit for undergraduate level. However, for postgraduate level, we may have different mathematical models used to describe single-phase transformer. Please, if anybody make his microphone on, please turn it off to avoid any noise. So this was the exact equivalent circuit we described or derived last classes. And as you can see, we have, again, I will repeat again, just to refresh your knowledge. Here we have R1, X1, which are resistance and leakage reactance of primary winding. We have RC1, XM1, which are core resistance and magnetization reactance of the core. Then we have XL2 prime and R2 prime, which are the reflected impedance of the secondary coil, where R2 is the resistance of the coil, and XL2 is the leakage reactance of the coil. So we have all of time, subscript 1 is for primary and subscript 2 is for secondary side. And using prime on the top of each symbol, XL2 prime, R2 prime, this means that these values are reflected or referred to the primary side. As you can see, now we have only one side. There is no magnetic coupling because we reflected all of the secondary side of transformer to the primary side now. So all of the values with superscript prime, these are transferred values from secondary to primary. Okay, so this is the equivalent circuit, or we call it exact equivalent circuit. Also, we agreed if we make some assumptions, we can make other approximated equivalent circuit. First approximation is to move the impedance of primary winding to the right-hand side here. This is to simplify the circuit in order to simply calculate the current of the second loop here, which is I2 prime. So simply we can calculate I2 prime as V1 divided by this impedance plus the impedance of the load. So this is simply the way to calculate I2 prime from this circuit. The assumption here is the voltage drop across the resistance and inductance of the primary side is very small, okay? And we can move it a bit here or neglect the voltage drop in order to make approximate solution or simplify the equivalent circuit. This is the first approximation, and this is what we are going to use a lot in our classes. There is another circuit here where the magnetization branch is neglected. As we discussed, the magnetization current is around 5% of the rated current. So we can neglect the magnetization branch, and the circuit in this case will be only one equivalent impedance, which is Z equivalent 1. 1 here means referred to primary or in the primary side, where R equivalent 1 equal to R1 plus R2 prime, and X equivalent 1 equal to X1 plus X2 prime. And similarly, we can transfer this to the secondary side to be Z equivalent to, as you can see here. So this is the primary side equivalent circuit, and this is the secondary side equivalent circuit. Okay, so these are the approximations used in the single phase transformer. In order to evaluate any transformer, let's return back again to the equivalent circuit here for the exact one. If we have a load connected here, and we need to calculate the supply voltage and current, and draw the power factor, and also calculate the efficiency of this transformer. In order to do all of that, we need first to identify the values of the transformer parameters. R1, X1, R2 prime, X2 prime, RC, XM. We need to find all of these parameters in order to calculate or evaluate the transformer performance. So we are going to describe experimental test that is used to determine the parameters of electrical transformer. Simply, if we have, let's make a small example. if we have impedance and we would like to calculate this impedance, sorry, not to calculate, we would like to test or know the value of this impedance, what we can do. يا شباب, if we have impedance in a box and we need to identify the value of this impedance, what we can do?
V over I.
So we need to make a test and
Voltage.
apply supply voltage, تمام, and measure the current. So V over I is going to give you the amount of impedance. However, what is the resistance and reactance values? How we can obtain these values?
By the power factor.
How we can get the power factor? Yani we now measured only voltage and the current.
We see the wave and the difference between them.
This is a method, and it's possible to use oscilloscope and monitor the voltage and the current signals and get the phase shift in order to get the power factor. However, if you have only some multimeters like voltmeter, ammeter, wattmeter, what you can do? Okay, so if we measure the power, so you have power, voltage, and the current. In this case, you can say the amount of power is going to be absorbed on the resistance. Is it right? So you can get the relation between power and the resistance easily according to the connection. Is it series connection or parallel connection? But you have to understand that all of power is going to be absorbed or drawn by the resistance. So we can get the value of resistance from the power, and based on that you can also calculate the reactive or the imaginary part of the impedance just from the triangle of the impedance. Just by the square root of z square minus r square you can get the reactance value. So these are the ways we can use if we have impedance and we need to identify the values of real and the imaginary part of this impedance. For our transformer, شباب, here, as you can see, the transformer is not single impedance. As you can see, we have primary winding equivalent circuit, core equivalent circuit, secondary winding equivalent circuit. So it's not easy to implement this directly on this circuit. However, if we can use this approximate equivalent circuit now, and we make some assumptions or some tests, we can use these tests to simplify the circuit. How? For instance, if you bring a transformer and make the transformer no load, which means there is no current moving in the secondary side, this means the voltage drop across this impedance will be 0. Is it right? يا شباب, if there is no current here, what will be the value of voltage drop here? If the current is 0?
0.
0, exactly. So in this case, the equivalent circuit only will be this part. Is it right? So this part represents the open circuit equivalent circuit, the open or no load equivalent circuit. So this is now no load equivalent circuit. Right. If you make a short circuit on the secondary side here, this means that a high current will move here and very small current is going to move here, صح? تمام يا شباب? Because the impedance here is very high, and we agreed together before that the current here is almost 5% of the overall current. So if we made short circuit, this means that the current which is moving here can be neglected, and we can remove all of these parallel branches. And we will have, in this case, only this impedance in series with the supply. So we can make now two tests, no load test and short circuit test. So simply, we have this is the equivalent circuit as we discussed. This is the no load equivalent circuit, and this is a short circuit equivalent circuit. Type. Regarding the experimental test, how we can make this test experimentally? Now, for the transformer connected to the devices, for the open circuit, we will leave the open circuit without any load, no load, and add voltmeter, ammeter, and wattmeter on the other side. So simply, like that, this is the transformer. We can add voltmeter or supply voltage with known value, ammeter and wattmeter, or here the voltmeter is measuring the volt here, and we keep the transformer here as open circuit. This test is preferred to made while the voltage is the rated of the transformer. Why? If we have a look here to this circuit, now, when we calculate the core loss of the transformer, we assume that the core loss is fixed amount. So we will define the value of RC, and the amount of power absorbed by the resistance RC will be fixed whatever the loading condition. So if you make the open circuit test at lower voltage, this means you will calculate the RC at lower power absorption, which means it will not give you the accurate value of core loss. So in open circuit test, you have to apply the rated transformer voltage. This is to calculate the RC or core resistance accurately. تمام؟ طيب. This is for open circuit. For short circuit, here, as you can see, we apply a voltage here and make a short circuit on the secondary side. A question for you: if you make short circuit on the supply at home, what will happen?
The electricity will shut off.
It will be shut down. Why? Because we have some breakers at the panel, okay, that will trip if the current exceeds a certain limit. This is normal. طبعا the current, theoretically, short circuit resistance is 0. So the current which is going to move in the short circuit will be infinity. Is it right? So in this case, we assume we will have very high current in the secondary side. طبعا not infinity, because we have already impedance in the secondary side, impedance of the transformer itself. So we will have current, but this current will be very high. For that, this test for the short circuit, this test is preferred to made using variable supply here, and start increasing the variable supply from 0 up till reaching to the rated current. The rated current. Now the question: what is the meaning of rated value? يا شباب, do you know the meaning of rated values? What's the meaning of rated values, شباب?
Can we say it is
Are these the values that
made for the wires, like a specific current that's made for the wires or for the equipment that we have?
Can you see the screen?
Yes.
Can you see this plate? This is called nameplate data. Nameplate data exists on all of the devices. Okay? On the nameplate data, we specify the rated values of the device. What's the meaning of rated values? Simply, for electrical devices like that, we have here nameplate data for electrical device. Here, this is for three-phase motor. Three-phase, this is symbol of phase. So three-phase motor, MG, kaza kaza, this is the number or serial number of the product. Okay, 50 hertz, this means that this device is working at 50 hertz. But is it meaning that it cannot work at 52, 55, 60? It's possible. However, you will not get the rated performance or the better performance of this machine. Okay. Again, here you have U, which is the supply voltage in Germany, standard in Germany, they do not make symbol V for volt, because يعني mathematically they cannot say V equal 220V. يعني mathematically is wrong, is it right? But you can say U equal 220V. This is mathematically right. For that, in Germany, they give different symbols for voltage and current. So U here means the voltage, 220 to 240 volt for delta connection, 380 to 415 for star connection volt. So this here, some values for volt. What are these values? These are the rated volt. So on the nameplate data, all of values are rated. Rated means the values that if you operate the machine or the device on these values, the machine is going to perform in the better way and perform safely without any problem. However, this doesn't mean that you cannot operate the machine at lower values. Yani if the current of a machine, the rated current for instance is 10 amps, this means you can upload or make loading on the machine up to 10 amps. So it can be loaded by 2 amps, 3 amps, 5 amps, up to 10 amps. 10 amps is the rated value or nominal value. If we increase the value of current by extra loading on the machine, if we increase the value of current, for instance, to 12 amps, this is mean here that there is an overload on the machine. The machine is overloaded now. تمام؟ طيب. Also, there is another value for current called the maximum current, not rated current. Maximum is the critical value that if the device is working at that value, the machine will be burned. Okay, so you cannot operate the machine at maximum values, but you should operate the machine at rated values. يا شباب, is the meaning of rated clear now? واضحة يا شباب ولا لا؟
Yes, yes.
جميل. So in the short circuit test, we apply variable voltage and increase the voltage after reaching to the rated current. If you reach to the rated current, stop increasing the volt and measure B, V, and I. So the outputs of these tests are nothing but P open circuit, I open circuit, V open circuit, which is V rated, P short circuit, V short circuit, and I short circuit, which is I rated. تمام كده يا شباب? These are the tests made in order to identify the transformer parameters.
Doctor,
تفضل.
can we find the rated current without looking at the plate data?
No, in order to know the rated current for any device, you have to check the nameplate data.
We cannot measure it.
You cannot. You can measure current, but how you will recognize that this is rated or not?
Oh, okay.
Okay. And if you have device, before connecting the device, you have to first check the rated voltage. For instance, here in Saudi Arabia, we have two different supplies, 110 and 220. If you bring supply 220 for load of 110, it will be burned, it will be damaged. So you have to check the nameplate first. Okay. Here in this example, it's example for identifying the transformer parameter. Here it's stated that tests are performed on a single phase 10 kVA. What is 10 kVA, Shabab? What is the meaning of this value?
Apparent power.
Actually, volt ampere is apparent power. This is right. But which value? Is it any value can be loaded for transformer or rated value or what?
Rated value, Doctor.
Rated. All of time, Shabab, the data given in the head of the problem is the nameplate data. So 10 kVA means that S rated or apparent power rated is 10 kVA. 2200 volt over 220 volt. So this means this is the turns ratio of the transformer. Now, what is exactly this value of volt? Is it the output volt or input volt of the transformer, يا شباب? If we go to the equivalent circuit again, here, this is the equivalent circuit, okay? يعني after making referring, you will have only 2200. There is no 220 anymore, okay? Assuming this transformer is for step down 1, and we referred all of the parameters to primary side, okay? Is it clear for you? خليني ارسمها لكم افضل بره. Can you see now the screen, يا شباب, the whiteboard?
Yes.
If we have transformer, and it's stated that this is 220 or 2200 volt, and this is 220 volt, okay? Or this is the Turner's ratio of the transformer. Now you have here some resistances and reactances. This is in primary and this is in secondary. So where will be the values? We have now V2 and we have V1. So what should be the value of 220 or 2200? All of time, شباب, we care about load. We care about the load. So if we say transformer is 220, the secondary is 220, this is mean that V2 equal to 20. So what will be the value of V1? You have to calculate V1 equal to V2 prime after referring to primary plus I multiplied by Z equivalent of transformer. So V1 all of time will be greater than V2. تمام يا شباب? According to the loading condition. ماشي? So all of time, when we have nameplate data, we will refer to V2 prime as the voltage of the transformer. So V2 prime now is 2200 volt. Is it clear? تمام يا شباب? So in our example here, turn to the other screen again. In our example here, the 220 volt or 2200 volt is referred to the V2 prime. Okay. So now we have single phase transformer. 10 kVA is the apparent power rated. V2 prime equal 2200 volt, or V2 equal to 220 volt. Frequency is 60 hertz. Now these are the measurements or the data obtained from the tests. We have open circuit test, and these are the data given at open circuit. As you can see here, it's stated that high voltage side is open. So if the high voltage side is open, the low voltage side will include all of measurements. So the voltage is 220 volt. The measured current is 2.5 amps. The wattmeter reading is 100 watts. For the short circuit, it's stated here that low voltage side is shorted. So the high voltage side has the measurements where the voltage is 150. The current is 4.55 amps, which is the rated current, and 215 is the reading of the wattmeter at short circuit test. Based on these values, the required here is to drive the parameters of the approximate equivalent circuit referred to the low voltage side and high voltage side. So شباب, we have now the rated values. These are the rated values written here. We have V high rated or V low rated. which is referred to as V2 prime and V2. So we highlighted here, which we refer to in our discussions as V2 prime. So this is now V2 prime, and this is V2. Okay. I high, so this is in the primary side, so this is represent I2 prime, and this represent I2. This is S rated. طبعا يا شباب for the power there is no side for the power. Power is power. Whatever the side, it will be the same. Okay. Let's start with the analysis of the open circuit and short circuit test. Starting with open circuit test, this is the equivalent circuit. And now we have the absorbed power for this circuit. We have the voltage applied and the absorbed current. So simply, because we have current, voltage, and power, we can say that the power which is going to be absorbed by this resistance equals V square divided R, because it's in parallel with the supply volt. Is it right? Can we say here, شباب, I1 square R core equal power?
Yes.
لا, yes, ازاي? Again, the question. Can we say I1 square multiplied by RC1 equals the absorbed power?
Oh, no, they are parallel.
Exactly. This is not the current which is flowing in the resistance. We can say IC1 square multiplied by RC. This is the value of power, okay? But not I1. And the measured current is I1 or IL. This is the measured current here. So what we can say here that VL square divided R will equal to the value of power. So power equal power equal V square divided R. So R equal V square, which is 220 square, divided by the power given in the example, power of no load test. So the value of resistance representing core is 484 ohms. Can you say, شباب, the value is high. All of time the value of resistance of core is high value. Also, now we got the value of R, we need to calculate X. How we can calculate X here? Simply, if you calculate the value of IC, so we can say that V divided RC equal IC, and you have the value of I total, so you can get IM. After getting IM, just divide V1 over IM, you can get the value of XM. So these are the steps used to calculate the values of RC and XM. Is it clear, يا شباب? Is there any problem? Right. This is now referred to low voltage side. Why? Because we applied the circuit measurements at low voltage side. We need to calculate these values referred to high voltage side. So simply we can use the Turner's ratio to transfer these values. So R core referred to high side equals A square multiplied by R core low side. So the value here, as you can see, 48.4 kilo ohm. Value is very, very high. Similarly, XM can be calculated. So Turner's ratio square multiplied by the value of reactance in the low side. So the value here is 8.94 kilo ohm. Can you see the values of RC and XM? Yani considered high because this is the normal or يعني this is the normal values for this branch. This branch all of time will have high impedance.
Doctor,
تفضل.
in part A, for calculating IML, why did he square IL and IC?
I5 is a complex current which is going to move in resistance and reactance. تمام؟ مظبوط ولا لا؟
Okay.
Okay. So you have the absolute value of I phi. and the absolute value of IC. As you can see, this is completely real, and this is completely imaginary. تمام? And this is absolute value. So simply you can say the imaginary part equal square root of 2 to I phi square minus IC square.
Okay.
For the short circuit test, we have power, voltage, and current as well. So this is the equivalent circuit for the approximated one we are going to derive the values. So this is now the equivalent circuit. When we make short circuit here, you can find the resistance as power divided I square, because it's series here. Is it right? So R equivalent equal to the short circuit power divided by I rated square, which is the I short circuit here. It's equals to 10.4 ohms. We have voltage and current, so we can calculate the impedance. Impedance equal voltage divided current. So 150 volt divided 4.55 ampere. This is the value of Z. You have Z and R. Simply you can calculate the value of reactance. And this is now the value of reactance. So we can use now the value of resistance, R equivalent and X equivalent here, and add it on the circuit, like shown here in this figure. However, if you would like to know the value of R1 and R2 prime, we can assume that R1 equal to R2 prime equal to R equivalent by 2, and similarly X1 equal to X2 prime equal to X equivalent over 2. If you would like to get the values in the other side, so simply you can use the Turner's ratio to get the value of R equivalent and X equivalent. So now this is the equivalent circuit referred to high voltage side, and this is the same equivalent circuit referred to low voltage side. Is it clear, شباب? Number B, express the excitation current as a percent or percentage of the rated current. We said before the no load current is around 5% of the full load current. Now we have the no load current, which is the open circuit current. Here it's given by 2.5 amps. And we already calculated the value of the rated current. So what is the percent now, شباب? Which value? What is the value of the rated current according to the meter of 2.5 ampere at no load? يعني which value we should divide? Is it 2.5 divided 4.5 or 45.5? ها شباب? Who can answer? مين معايا يا شباب؟
Shouldn't we divide it by 45.5 since these measurements were taken from the low side?
Exactly. This is very good. What's your name?
Ali Al-Khazan.
ثواني علي. علي الخزر. Okay, علي تمام. Good. So, as you can see, this is now the test of open circuit, and we measured or add the meters in the low voltage side at the 220 volt. So we should calculate or refer this value of current to the low voltage side current, which is 45.5 amps. So just divide 2.5 over 45.5 and multiply by 100. You will find the value here. It's 5.5%. around 5% as we described previously. تمام يا شباب؟ Right. Number C, determine the power factor for the no load and short circuit test. طبعا يعني either no load or short circuit test we have no load. تمام؟ يعني for short circuit and no load tests there is no load connected to the transformer. يعني it's either open circuit or short circuit. So this power factor will not give impression for the operating power factor for loads, which is يعني basically depend on the load power factor. So this is just to recognize the values of power factor at short circuit and open circuit. Simply, you can use the relation now. You have power, voltage, and current. You can say power factor equal to power divided by voltage multiplied by current. So, at as you can see, at no load, the power factor is 100 divided by 220 or 220 multiplied by 2.5 amps. So the power factor is 0.182 lagging. طبعا شباب لازم يعني here is the power factor is lagging because the circuit is inductive. تمام. All of the transformer circuit is inductive now. And for a short circuit condition, the power divided by S or apparent power equals to 215 watt divided by 150 volt multiplied by 4.55 amps, which is 0.315 lagging power factor. So these are the values of power factor during open circuit and short circuit tests. Right. And voltage regulation, we can start voltage regulation inshallah in the next class. Now we will open the discussion if anybody has any question.